So today we discuss conditional probability. And as I was just saying a minute ago, a little bit different from the theoretical we talked about yesterday in that there's a little more to think about. So here up at the top, let's chat about what conditional actually is here at the start. So given two events, A and B, conditional probability is the probability of event B occurring knowing that event A has already occurred. It already happened. So if this happens, how does that affect how things are going to look overall? So if I see it written in just its simple form, it'll look something like this. Now, it doesn't mean that we say, hey, what's the probability of B divided by A? Because that's kind of what it looks like. But that's not how this is read. This would be read, I'm looking to find the probability of B given A. And the key word here is going to be given. And sometimes it may be a word like if, you know, or if this occurs. And the reason that given word is so important is it's going to be kind of our cutoff point on how our formula gets set up. Because when we're doing conditional probability, it's going to be a fraction like every other probability is, a ratio. And so the way it works is it's going to be the probability of both events together, A and B occurring, over the probability of A. And the probability of A is found after the word given, or after the word if you know, something to that effect. So I'm always going to know where my denominator is, and then both things together will form my numerator when I'm dealing with conditional probability. So you're like, okay, so how does that work as far as I'm concerned? Okay, so if we look at number 2, we've got a number from 1 to 100 is randomly selected. Okay, here comes the question. What is the probability that it is a perfect square? There's my given. That it is an odd number. Okay, so we just got done saying for my fraction, the denominator, the bottom of it, is going to be the part that's after given. Given it is an odd number. Now, will you have to write out in words what it is in every single one when you're doing these? More than likely not, but especially on a note sheet, being able to see, well, where those numbers come from is a good thing. My numerator is the odd number as well. But it's also, let's read the rest. What's the probability that it's a perfect square? So here's where I'm going to get my numbers from. My first thing is I got to kind of narrow this down a little bit. I look up there and it says, okay, a number from 1 to 100. Now, do I mean you have to sit there and write out every single number from 1 to 100? I certainly hope not. So if I have 100 numbers that are in order, how many of them are going to be odd? 50. Okay, half of them are. Now, people watching later, you won't be able to see this, but up on the board, I went up to 50 to kind of let you see. And what you'll notice is like the 1s column, 3 column, the 5, the 7, and the 9 column, those would be my odd numbers. That's half my columns. So anytime you're talking odd, even, half the numbers are odd, half are even when they're in order like this. Now, the numerator, an odd number, but a perfect square. There's my perfect squares that are between 1 and 100, which you should know at this point. But we're only interested not in just the perfect squares, but the odd perfect squares, of which there are 1, 2, 3, 4, 5. And that would give me my probability. Now I still need to take any fraction I get and reduce it. A quick math enter would do the trick. But that's how we're going to break these down. So what after the given, that's my denominator. The two events together, the probabilities of them together form my numerator. And the denominator will always be larger.
39 is a prime number.
Oh my gosh, you're right. I'm going to have to get back to that here in a bit. You are absolutely positively correct. We will get actually. So as we continue to look at these, you notice a whole lot of wordiness. It's going to be more a fact of us trying to work on breaking these down. So this next one, all right. 62 people are taking yoga. 48 people are taking a spinning class. 15 people take yoga and a spinning class. All right, here we go. If a person from these groups is selected at random, find the probability that he or she takes yoga. If you know, that's kind of like given here, they take spinning class. So again, I'm going to break this down. What's after my given, my if you know? They take spinning class. Okay, so that's going to be my denominator. Then I go back before the given. Okay, find the probability he or she takes yoga class. So it's going to be spinning and yoga, A and B, together that create the probability for my numerator. Now, sometimes I may be able to pick this up straight from the problem. Sometimes maybe I'd look at it more visually, and we'll try to do both here. Excuse me. So I go back through and I start reading. 62 people take yoga, 48 people take spinning. Okay, 48 people take spinning. Pick that up right away. Get that in my denominator. And I keep reading. 15 people that take yoga also take spinning. Oh, spinning and yoga. 15 out of 48. I reduce it if I can, either with math enter or knowing they're both divisible by 3, and I get my probability. Now, if you're a little more visual of a learner, okay, we have a possible option here for you. You may have been introduced, you probably should have been at some point before, to what's called a Venn diagram, which basically takes our two events, our yoga and our spinning class, and we realize that there's an overlap between the two. So while we realize that our yoga participants equal 62, our spinning participants equal 48, we know that 15 take both. So there's 15 that would plug into this middle area. So normally people at this point look at me and they go, well, why did you put the 62 and the 48 outside the circles? Why didn't you put them in here? Because this circle represents all of my spinners, of which there's 48 total. If there's 48 total, 15 of them do both, and they're included. So this other value that's in here has to be a number that these two added up, this circle total, equals 48. And the same thing with my yoga. The total circle is going to equal 62, but 15 of it's already taken up. I'd have 47 more. Now, some problems, that will give you more information than others. Here, I'd have been able to see, oh, well, they have the 15 in common. Okay, I see that. And then I'd look here and say, oh, the spinning's 48 total. Even if I looked at it this way, 33 and 15 is 48, and I can do it visually. How you do it is up to you. Some of you like the picture, some of you like just looking at the numbers, but they both get me to the same answer. And that same thing is going to happen here on number 4. We have 30 students in Mrs. Smith's math class. 13 are athletes, 9 are in band. 3 of the athletes are also in band, so they do both. If one student is chosen at random, find the probability that this student is in band, if it is known that they are not an athlete. Okay, so I find my part after my given, my it is known. And this time I see that's not an athlete. Okay, it's our complement. Then I keep looking, and I'm like, okay, so my numerator is not an athlete. Find the probability the student is in band. So not an athlete and in band. So I start to look at that, and I go, okay, let's see here. The 30 students in class, 13 are athletes, 9 are in band. It doesn't tell me how many are not athletes. Looks like I'm going to have to do a little math here. So let's see. I know how many students are in the class. I know how many are athletes. How can I figure out how many aren't? Subtract, okay? If I have 30 students, and I have 13 that are athletes, that leaves me 17 that aren't. And that would be my denominator. So then I look up at the top, and I go, okay, not an athlete, but in the band. So here's the other information I've got. 3 of the athletes are in band. So similar to what we just did, I know there's 9 students that are in band, but I know 3 of them are athletes, and that's not the group I'm looking for. I'm looking for the complement. I'm looking for the opposite. So I'm going to have 6 band non-athletes. So sometimes we're going to have to get a little bit creative with this. Okay, I may have to do a little extra math work to find out my complements. Now, this is a problem where the Venn diagram might actually be more helpful, since both of the numbers I needed weren't actually given to me in the problem here. If I were to look at this as another Venn diagram, so we've got athletes and we've got band members. I know 3 of the athletes are also in band, so I know that middle value. I also know that there's 13 total athletes. Well, 3 of them are involved here, 13 total. So this would have to be 10, because 10 and 3 would add up to 13. Band, I know there's 9. That'd be 6. So here, I'd be able to look and see, hey, if these are athletes in band, these have to be people who are in band that aren't athletes. There's my 6. Okay. Not an athlete. I'd look and I'd go, well, 13 are athletes. There's 30 total. Must mean the rest of the group is not athletes. So I can visually start to see some of that too if it's not making sense. So if in doubt, try a picture out. Hey, I rhymed. Amazing. Okay, so that's some of our options. Does it mean that every single problem we're doing with these are going to be really, really wordy? No. Not at all. So as we move down, there's one other type of problem that we can use this in. And it's what's called a two-way table. So as I'm doing these, what I'm going to have is I'm going to have a chart that works like this, where it basically gives me the information like it did in the paragraphs up here. So here's how we're going to do this. The table shows the result of a poll of 50 randomly selected students who were asked whether their preference was to watch hockey or football. Find each probability. Okay, I'm going to make a suggestion. If there's not a totals area, and on a lot of these there won't be, I would go ahead and total both my columns and my rows. And here's what I'm attempting to do. What should occur here is that my rows and my columns add up to the same thing. 28 and 22 should add to the same thing as 24 and 26, which is 50. And I also kind of have a double check in this one because they said in a result of a poll of 50. So when I go to do the solving now, okay, this little slash here, like it was way up the top of this page, what this says is, what's the probability that a student preferred football given the student was a girl? That's what the slash is. It's my given. It's my it is known. So when I go to build these fractions, whatever's after the slash is my denominator. And then both what's before and after the slash is my numerator. And now I just go to my chart, okay? How many girls are there? Oh, that's why you went ahead and added those up, because I needed the total of all the girls. And then my numerator is the girls, so I stay in this column that like football. And like I mentioned up towards the top, your numerator will always be smaller than your denominator. If they get flipped somehow, it means some didn't quite go right. And I get my value. Same thing for B. Be careful. Especially if you do one like this, you'll be like, oh, I put boy on the bottom. No, we don't. Whatever's after the slash is my denominator. And then the two together are my numerator. So my denominator is hockey, which is this row right here. And again, I see why I put that value in. Boy that prefers hockey. Okay, here's my hockey. Boys that prefer hockey right there. 10 out of 26. And a little math enter, or a little knowing I got to divide by 2 will get me there. Okay, as long as I keep straight. Denominator, both go in the numerator. Should be good with those. And that's our main focus. Yes, sir? When we're looking at the denominator, though, it's hockey that I'm looking at for my total. So I'm going straight across here. The boys come into play when I'm doing boys that like hockey up in the numerator. So when I'm looking for boys that like hockey, it's just going to be that group. Because if I use 28, that would be including the football players. And I just want the hockey players here. Good question. Yeah. So as we flip over, we're in the same idea here. Just going to get a little more practice at some of our situations. So here we have 150 middle school students that were asked if they take French or Spanish. Again, I notice there's no totals anywhere. So I'm going to go ahead and I'm going to total up each of the columns and each of the rows. And they should, since they gave me the value, they should add up to 150. If they don't, again, go back and check your addition with your rows or columns to make sure you didn't just make a quick error. But I do that in this case, and I notice, nope, they both equal 150. Feeling good. The only other real thing I've got to watch for now is if I throw a curveball on you. You're like, uh-oh, what does he mean by a curveball? Okay, letter A. A 7th grader who takes French. Notice, there's no word given. There's no slash. So what I'm going to do is I'm going to go find, okay, 7th grader who takes French. There's 25 of them. How many total students are there? 150. When there's no restriction given, when there's no given, no slash, no some restrictor, you're always going to use your entire sample space as your denominator. So whatever this number, this grand total would be, I still reduce it, but we work it that way. Now when the slash, the given slash, comes back into play, though, we just roll with it. We go, okay, after the slash, After the given slash says Spanish. So Spanish is my denominator. And both are my numerator. So 8th graders taking Spanish. So I go looking. I want all of my Spanish speakers. Okay? Grand total down here is 68. But then for the numerator, I want a narrower group. I just want the 8th graders that are taking Spanish. And if I do a math enter and I get back the exact same fraction again, it just means it's simplified already. And we're good with that. And we go. So just keep drilling into yourself. Whatever is after is my denominator. Both together is my numerator. So again, my denominator is all the 6th graders. So they're going along here. So I'd have 42 of them. But then it narrows down again, becomes more specific. 6th graders that took French. Right there. Double check to make sure it doesn't reduce anymore. Go on about your business. So you're like, okay, yeah, I kind of starting to see this a bit. So let me jump down to 6. There's one more twist to play with. The table shows the results of a poll of randomly selected juniors and seniors who were asked if they attended prom. Notice there's no total value given this time like there was in 4 or 5. Means even more in this case, I need to make sure that I add up my columns, I add up my rows, and make sure that they equal. Even though I don't know what the grand total should be this time, it still should be the same when I add down and add across. And as long as that's the case, you should feel pretty good that you're doing it the right way. So now, similar to what we had in the last one, letter A, notice, no restriction, no given, no slash. Probability a junior that did not attend prom. Okay, junior, no, is 56 out of the entire sample space. That's why we do the totals. And then reduce the fraction down as far as it goes. But then the ones after that go back to being more classic on what we were doing. Okay? Whatever's after my given is my denominator, my senior. And the two together, no prom senior, is what my numerator is going to be. And again, all seniors versus seniors that chose not to go to prom. Give it a quick check to see if it reduces. And if it does not, we go about our business right there. Now, these tables can take on one more type of view. Because everything we have here is whole numbers. We're getting them into simplified fractions. We're going. The last part we have that rolls with these are what are called frequencies. And there's 2 types. There is called the joint relative frequency, which will be this area right here. Just like the tables we've been doing up above where you have the numbers already. Okay? Each individual category gets its own box. When it becomes a marginal frequency, that's my totals, like what we did along the edges here. So it's just kind of putting both into one. So, when we get down here to 7, first job, you know what it is, totals. Still going to need them. So we start doing a little addition down. We do a little addition horizontally. Cross our fingers that the numbers in the middle equal the same thing. 30 plus 130 is 160. 68 plus 72 plus 20 is 160. So that is going to be our denominator for all these fractions, because we're going to go into calculator mode here. When we're doing frequencies, basically we're doing percentages in decimal form. So we're not going to worry about math enter-enders because we're not doing fractions. We're going to get very exact. You're like, okay, so why would somebody want to do this? This example is a good life example. If you're running an airline, okay, if you're in management and you're trying to figure out, hey, how many of my people fly coach versus first class? How many bags do they typically carry? Maybe you start figuring out what you're going to charge people to bring a bag on. Maybe you start figuring out, hey, am I going to try and encourage them to do this by bringing the price down? You kind of play with it. So what we're going to do to fill in these boxes, once I scooch this over a little more. Okay. If some of you could see it, I will bring this down because I always like to be amused when I'm doing this. It's always fun to see how my people stay amused when they're in class with stuff. So yes, people out there on the World Wide Web, this is what my students focus on during the day that it's fun to stay at the YMCA. Okay, now that we've gotten that factoid out of the way, we're going to take a peek at actually calculating these frequencies. Oh. So we're going to take each number that's in the box, and we're going to keep dividing all these by 160. And the decimals that we get, okay, so basically that 0.1 would tell us that 10%. First class, 2 bags. And I'm just going to keep working these. All the way through, including my totals, because I do have a total column here. And just like it would in any of these charts, my numbers horizontally should add up. 0.1 plus 0.325 equals that, so that's sensible. I will try to get back on the screen here in just a second here. All right, we've made it. Oops, it would help if I actually hit enter. There we go. And I'm just working my way along. And so what we'll have here in a moment, once we have everything filled out, will be every single possibility and what percentage of a probability that particular event has in occurring. Does it take a little bit of work? Yeah. But when we see the info that we can get out of it, and it also lets us make sure that our math worked out. You're like, how do I know that? Because basically what we're doing here is my totals across the bottom and across here should always equal 1. Why is that? If these are percentages, we want it to equal 100%. We want it to add up to the total that we're going to have at the end. So I can look at this now if I'm trying to figure this out and say, wow, check this out. 37%, 32% of my coach class people are having like 1 or 2 bags. Now I got to figure out, am I going to charge them more or am I going to charge them less to try and get more people? Ooh, I don't have many first class people. Maybe I need to reduce my prices. There's a lot of information I can get out of this to help me as I'm moving forward. But for our purposes here, we got a few questions down here at the bottom. Probability that a coach class passenger that did not check any bags. No restriction, no slash, no given. So coach class, no checked bags. 0.1125. Done. You're like, I don't have to divide it by 160? No, we already divided all of these by the 160. So it's like we did that work ahead of time when we're doing the frequency tables. Now, B, we got to be careful. A first-class passenger that checked at least 1 bag. Ooh, at least 1 bag means it may be 1. or it may be 2. So, how do we deal with that? Well, we go to first class passenger, we go to 1 bag, we write the value down. We go to first class passenger, we go to 2 bags, and we add, bless you, the values together. So I can even combine my data to get a larger picture. Okay, or maybe not as specific of a picture as some situations. But again, there was no restriction. Once the restriction comes back into play, we go back to doing it like we were before. So after my given, so 1 bag would be my denominator. Coach class, 1 bag, is my numerator, just like it has been. And so when I go to do my calculating this time, I just go back and I go, okay, 1 baggers. All of the 1 baggers. So I got to go to the total count. 4, 5. Okay. Coach, 1 bag. Take that value. And then we're just going to divide them. So like 0.83. So I basically am telling myself if they check the bag, they're probably in the coach class because 83% of them are. Okay, same idea on the last one. First class is after my given. 2 bags. So 2 bags. First class. So let's see. First class needs total. Two bags, first class. And get my percentage, or my decimal version of it. We will be seeing more of these tomorrow in a worksheet format. But for now, you've got a good start to get going on your worksheet. Try those out some, check answers, and see me if you've got it.